Instead of value engineering, we're engineering value. Bringing you thought leadership on how to find success in U.S. manufacturing, this is Engineering Value, a Draper podcast.
Welcome to Engineering Value. I'm your host, Sean Heath, and my guest on the podcast today is Steve Edwards. He's the Director of National Accounts and Special Projects for Draper. Steve, how are you today?
I'm great, Sean. How are you doing?
I'm doing really well. Thank you for asking. Warming up a little bit here. I think spring's right around the corner. So while hay fever is on its way, I'm okay with warmer temperatures.
My daffodils love it.
The title of the podcast is Engineering Value. Could we start off with you clarifying once and for all value engineering versus engineering value?
Yeah, sure. The general conception or understanding in the construction industry, value engineering means cutting cost, just reducing the quality and all of the components to reduce the cost of the project. Engineering value is kind of the more optimum phrase where you're looking at ways to retain the quality and the value with a reduction in cost.
Right, because value engineering generally, I think, probably cheap would be,
Yep.
or cut corners might be a way to paraphrase that, whereas engineering value, as you mentioned, is there's no way we can't do this smarter and save some money without lowering the quality.
That's exactly right. Yep.
That mindset, I would imagine, causes quite a bit of challenge on a daily basis because there is another concept in construction, the race to the bottom. Is race to the bottom one of your least favorite phrases in the industry?
Absolutely. That's kind of the definition of cutting all of the quality out of the project and building it as cheaply as possible.
Can we talk about some of the downsides that come along with that mindset? And that's a very pervasive, the bottom line, man, it's always just hanging over your head like the sword of Damocles. But you don't have to feel that omnipresent doom at, we've got to come in under budget, because sometimes maybe a budget wasn't set realistically.
Frequently the case. General contractors usually start off with a kind of a preset allocation. Say the owner wants to spend $200 a square foot, and the general contractor plugs $200 a square foot into a spreadsheet, and that tells them that component X, maybe it's the flooring is going to be 6%, and the furnishings are going to be 1.5%, and that's instantly now set the budget without any actual regard for what the functionality of anything's supposed to be.
And not only that, but here's a breaking news. The world is constantly changing. Prices fluctuate. Sometimes materials are difficult to acquire, which could cause the cost of something that you believe is going to cost 6%, as you mentioned, for example, flooring. Guess what? Flooring's actually 7% because of a cost increase somewhere. There has to be an incredible amount of flexibility in the world of concrete construction.
Yeah, you'd think so. It should be, more of a interactive approach to developing budgets rather than kind of starting off with pre-assigned values, I think.
I would like to talk about roller shades and a building's perimeter because I know you deal with that constantly. Can you talk to me about how at Draper your engineering and then the capabilities and experience that you have come in to a project when roller shades are part of the desired final product?
Yeah, so there are a lot of facets to that question. The window perimeter, the area where the exterior envelope of the building meets up to the ceiling, is a transition that isn't dealt with very well within the architectural and interior design profession. The core and shell architect is responsible for the exterior envelope, and the interior designers have everything kind of 6 inches in towards inside the building, and that little sliver of space right at the perimeter doesn't get dealt with very well. So at Draper, we specialize in that particular area as it relates to the window shades. So roller shades can be recessed into a shade pocket at that perimeter, or they can be mounted inside the window mullions. So kind of separating which building component the roller shades are connecting to. And that makes a big difference in how the interior develops out. And so that's where we focus our expertise.
Is there a point in a project that is too early to start planning the shade component, or is that one of the dumbest questions you've ever heard?
No, not at all. We would probably not be very helpful if you're doing site planning and building massing at the you know, urban scale. But as you come into exterior envelope development in schematic design as a core and shell architect, we'd be very comfortable having a conversation right there, and all the way through the rest of the process.
As we talk about engineering value, the more closely Draper can be associated and involved in that process, ultimately, 99.9% of the time, that's where you start to generate savings. It's when you have to go back in at the end and the egg's already scrambled that then you want to add the cheese. It's just not quite the same, right?
Well, that's true. The only maybe difference is that when we're involved early on with that engineered value approach, you don't really notice where the cost savings is coming from. When you come at it from the end of the process, trying to get the sausage out of the omelet, it's it becomes readily identifiable how you're saving money. But at the same time, the design professionals have already spent a good deal of time developing everything, so it becomes a much harder process.
I know a bit about Draper, and I get a very clear feeling that with your track record, you really love being able to save money for a client. Can you talk to me about a real world example of this? I know you do it all the time, so it'll be probably difficult for you to choose just one or two examples, but can you give me an example of a situation where you're really proud of the money you were able to save?
Yeah, a couple things jump to mind. Probably the first one that jumps out at me was working on a mid-rise multi-tenant office building, and the architects had detailed the shades to be in a recessed ceiling pocket. That ceiling pocket was supposed to be supported from the slab above, and that construction detail ran on the order of about $28 a linear foot. But unfortunately, the general contractor hadn't budgeted anything at all for the framing or the pocket. So working with the GC, we then turned around and said, well, what happens if we mount the shades between the window mullions using a fascia, which is kind of like a valance that covers over the roller shade, and custom finish the fascia so that it matches the window mullions. That completely eliminated the need for all of that framing, saved, $28, $30 a linear foot, which was a pretty substantial number, even though the shades ended up costing them a little bit more because of that custom fascia. They still saved something like $250,000 on the project.
How do you approach a system where the issue's not the space, but it's the distance that you have to cover?
Yeah, so the difference between an inside mount roller shade where you have one operator, whether it's a chain for a manual shade or a motor for a motorized shade, in a window mullion space that's typically maybe 5 feet wide, versus trying to optimize the use of that operator. And I'm thinking now that we're talking about motorized shades. In order to optimize the cost of the motor and the wiring that goes into that, you want to move the shades outside of the window mullions so that you can link them together, running down the facade. So maybe cover 25 to 30 feet of window facade being operated by a single motor. The individual shade panels are the same, relatively speaking, but you're operating them with a single motor. That generally is going to substantially reduce the cost of the motorization just by moving it inside the window mullions as opposed to running it between the window mullions.
So you're able to chain together several motors and use one control panel for that, I guess, pod or that group of windows?
What I'm really talking about is having one motor operate several groups of shade, several shade panels. So if you think about a building having 5 or 6 window bays in a 30-foot section of curtain wall, having one motor operate that entire 30-foot section of facade, as opposed to having 5 motors operate that. So that's the first cost savings right there, is just utilizing fewer motors to operate more panels. Then you talk about grouping and how you group the motors together from a control perspective and how that can reduce costs. So there's kind of lots of levels as we peel the onion back.
I'm not the only person who really thinks that motorized shades are cool. Is that a pretty standard desire now in office buildings? Do clients, as a general rule, do more of them want motorized shades than not?
Yeah, definitely. Big trend, big trend.
So it's the cool thing, right?
Yep, yep. It's yeah, I don't know if it's the right without being pejorative, but the hipsters really kind of dig that whole thing where the building envelope just responds to the exterior conditions where the sun is and adjusts itself to accommodate their preferences.
I don't think that's a pejorative at all. If that makes somebody a hipster, I'm a hipster. I refuse to grow a lumberjack beard, but I like cool gadgets.
Yeah, absolutely.
When you're coming up with a solution for a customer, I'm assuming that you run into fabric challenges or fabric choice challenges based on the environment of the project that you're working on.
So the real challenge is the understanding or the appropriateness of a selection. An architectural firm may have a kind of a preset standard in their mind. Maybe everything that they do needs to be PVC free as part of their environmental standards or their interest in promoting a more healthy workplace. And then they try to apply that to a project without understanding necessarily what the cost implications are. And that PVC free fabric specification may not align with the owner's desires or values. They may need a fabric that's more durable, more readily cleanable. For example, the PVC-free fabrics that are available today are not as cleanable as the PVC fabrics are. So, you could maybe drive the cost up on a hospital project by 30 to 40% just in your fabric selection, and the owner has no idea that they're paying that premium, and they really have no interest in paying that premium. So a simple change in that fabric spec can really save a lot of money.
What is the one fact that you like telling people that gets the most shocked response?
I think the biggest thing is that our particular niche, the roller shades themselves are generally in the range of 0.5 to 1% of the total construction cost. And when you apply value engineering in kind of a very ham-handed meat axe kind of way, you can have a really substantial impact on the end user worker productivity. And that worker productivity far outweighs the short-term savings on window treatments. And an example I'd like to kind of emphasize is that when you value engineer motorized shades down to manual shades, you may save roughly $50,000 on a 20,000 square foot space. That space may house up to 180 employees. If you took a very conservative $40,000 a year salary with a burden rate of about 40%, the cost of those employees is roughly $10 million a year. A 0.5% increase in productivity from optimizing the glare control and view to the exterior, and that's a lowball estimate based on all of the daylight studies that have been done. That 0.5% increase in productivity would pay for that upgrade in the first year. So that's just kind of a crazy application of value engineering.
Today on the podcast, it has been an absolute pleasure for me to have a conversation with Steve Edwards. He is the Director of National Accounts and Special Projects for Draper. Steve, thank you so much for taking the time today. I really have enjoyed this.
It's been my pleasure. Thank you.